which logically in countries with a lower salary is giving the conclusion to say, okay, pneumatic 1-inch, 2-inch, we can't do that, we don't have the technology, better come, let's do it ourselves.
Thank you very much, Jean-Christophe.
Thank you.
And for the final presentation tonight, I'd like to introduce Peter Buberstinger, who is currently managing the video digitization development at the Austrian Mediatek. And his talk is called Review and Comparison of FFV1 versus other lossless video codecs for long-term preservation.
Yes. Oh, well, while we're figuring out how we're going to get the screen set up, I must make a small correction, because when I handed in my application for being here, I was still at the Mediatek, which I'm not anymore since December. Sorry, my bad. I didn't read the fine print when you showed it to me. How much time do we actually have, since we're a bit late?
Well, the session finishes at 6:30.
Okay. One thing about what Christophe said when asking your superiors, if you're a public institution that fund you, you go like, if you don't give us money, we will not be able to do our work. I would like to recommend the cost of inaction calculator. In case you want to have numbers, it's if you just point in your favorite search engine, AV preserve cost of inaction calculator. I think it's coi.avpreserve.com or something, but you probably find it online. It can give you nice numbers that you can give to your superiors and say, this is actually, when we start next year, we're losing money and we're losing content and so on. It's really nice for having this conversation. The second thing is I want to thank Dieter Schüller and especially Reto for making it possible for me being here. And let's get into the topic. What I'm going to speak about is the lossless codec FFV1. I'm really surprised that it popped up really often by not me here. So it is a mathematically lossless codec that kind of originated in a different way that formats usually do as we know them. In this presentation, I'm going to go into topics about performance comparison, because that's the first thing that people are interested in. Then accessibility and interoperability, like how do I use it, or how does it work, and stuff like this. Sustainability, of course, we're speaking about long-term preservation, and I'm serious about long-term. I say this is infinity +1, just to be sure. Standardization, we've touched it, but I'll also grab it up a bit. And then about transcoding and nonlinear editing and real-world experience. So let's get started with how did all this start, actually? Well, I didn't write FFV1. Couldn't do that. That was Michael Niedermeyer, who was project leader of the FFmpeg project. He did that in 2003, and in 2006 he said, it seems it's stable enough, I freeze the bit stream, and so it's guaranteed that all the files that are created since 2006, you can open them. Nobody cared, nobody knew, nobody used this codec, and in 2009, when the Austrian Mediatek asked me if I have any idea what they could use for video digitization, we sat together and we said, well, let's talk to others, what they are using. And we didn't want to go for another format. Oh, no. It was just that we asked around. We said, OK, the condition, like the prerequisite is we want to do lossless or uncompressed. But probably we won't be able to afford uncompressed for several reasons. So what about lossless? We asked around about the few institutions that actually were doing lossless at that time. And they said, yeah, they produce files, but they can't really handle them. They put them in the archive, and they use the lossy copy for everything else. And for several reasons, I don't want to go into details here. So Hermann from the Mediatek and I, we sat together and we thought, like, okay, this is a problem. Let's look for a solution. I'm a tech guy. I studied computer science. For me, this was like a problem. Let's look for a solution. So we kind of stumbled over FFV1 that was mentioned in a lossless codec comparison, and it scored really good. So I looked into it, and I saw in the code it was marked as experimental. I said, no way, we're going to use this. I contacted the developer, and he said, "Oh, sorry, I forgot to remove these words. It's stable since 3 years. Have fun." So yeah, moving forward in the timeline, it couldn't do multi-threading. It was fine for SD material in real time, so we were able to use it. And then we grabbed together some money, and others also chipped in the last minute to do improvements. So now it can do multi-threading, also added up to 14 bits per component RGB. It could do more, but it would require some more changes. If you need it, we can talk about this. And also slice CRC. As was mentioned previously by Mr. Hooper, it is very important or interesting to have a format that is robust in itself. So FFV1 in the current version has CRC information inside the bitstream, so it knows whether it's happy or not. Like if all the bits are sane, this makes it possible that if you do mass transcodings or if you just open the material for editing over a network and something happens, like a bit doesn't make it correctly over the line, it just the decoder knows, so it doesn't have to crash, and then the decoder can choose what to do with it, error concealment or not. Stuff like that. Well, then in August 2013, after I ran like massive tests of this new version with several hundred reference videos from zif.org and other publicly available test videos that I could get my hands on, we were able to officially freeze the bitstream and release FFV 1.3, being able to guarantee that files produced since then will be able to be opened in the future by the decoder. Now, the Performer project, as Erwin already mentioned, also plays a nice role in the conformance checking and the sustainability, and also the standardization, which is currently in progress. That's the timeline of what happened previously in FFV1. So about the features, which might be interesting for you, it supports 2 color spaces at the moment, which is YUV, up to 16 bits per component, and RGB with up to 14 bits per component, and gray with 16 bits. Several subsampling, as well as always lossless. I mention this because some other codecs that do lossless have lossless as an option. This means, since lossy is very popular, because it's very, very nice to have smaller files, the lossless option is very often, if you, like, whenever I asked people or I really looked at systems, very often the lossless option was kind of the stepchild option, hardly ever implemented. For H.264, for example, it's even mentioned that if you do H.264 lossless, you should be aware that hardly anyone implements it. And if another codec has this option, it might not be tested as well. So with this, it just does lossless, so you can't even misconfigure and say, oops, we did lossy and didn't actually know it. It's multi-threading, so if you shoot bigger material and large resolution in a higher bit depth at it, you can now scale the machine to make it work, which wasn't possible with the version 1 because it didn't make use of the additional CPU cores. Slice CRCs, as I mentioned previously, these are checksums inside the bitstream so that it knows if it's happy or not, or still good. Small performance comparison in colors. Actually, I ran that on my home computer. So these numbers, if you use better hardware, you get better numbers. I chose JB2000 lossless, H.264 lossless, FFV1 in version 1 and 3, BBC's direct codec, and in relation to the size of uncompressed. So if you look at the yellow parts, that's the size. So you see uncompressed, it's 100%. And the compression of these codecs is like almost the same. FFV1 being quite good with this material. In other tests, it has shown in reference to JB2000 lossless that it's like sometimes a bit bigger, sometimes a bit smaller, so varies depending on what you feed into it. In terms of speed, I must say that when I made these tests, the JB2000 implementation that I could use, that I could verify that it was actually lossless, didn't do multi-threading. So this is why it scores really badly. So if you have a multi-threading JB2000 version, it scores way better. But still, in the tests we made, it was so that on the same machine, you had JB2000 lossless SD material, all the cores up to 90% load, with FFV1 on the same machine, same input, same material, about 70% load. So it's just way faster with almost the same compression ratio. As I said, we didn't want to have a new format, no format war. Actually, we just wanted something that works, and this was just too good to be true to not use it. Moving on, accessibility. Yes, it's open source since day zero. And open source, I don't want you to mistake it for, oh, this is the free stuff that we don't have to pay for. And if something goes wrong or doesn't work, we just complain and say, oh, yeah, well, we didn't pay anything for it. So what did you expect? No, yes, but basically, the important part is that this license was the reason why in the archive we said we can use it for preservation, although it's not standardized and it's originated in a project by somebody who's just happened to be good at math. Because these freedoms by license definition to use, study, share, and improve stuff allowed us, first of all, to archive the source code. This is like archiving your replayer, including schematics and building components. So I was like, from an IT guy point of view, this is as good as it gets for long-term preservation. We can use this. If somebody wants a standard label on it, okay, I won't stop them. The fun part is, it's not only available and accessible for end users. If anybody wants to support this codec, well, they can. So these freedoms apply to end users and vendors. About interoperability, I would like to go into another point where FFV1 is slightly different from what you usually experience in the real world out there. There's theory. People call it paper standards. And I, as a programmer, okay, who doesn't love Lego? Lego is great. I didn't rip this off from Brecht, we just happened to have the same idea, and it's a carriage just by coincidence. Well, so this is like what it's supposed to be. So you get the construction plan. So you go to whatever standardization committee has your standard papers, you retrieve them, and I, as a developer, I did this in the past, you read through these hundreds and thousands of pages, less possible errors to make. But, well, then there are implementations. These are basically interpretations of the theory. So you see the carriage down there below, and that is also a Lego carriage, but it's slightly different. And then if you have a complicated format, some choose to only implement parts of it. Still, yeah, it's part of the standard, but they didn't do all the features, and they even did bling bling on the carriage there. So as you see, the theory might differ from practice, but this is what my grandmother already told me when I was a kid, and we see it in digital again. Now, the third version of this carriage is something that you really run across in real life. This is not Lego. This is basically proprietary stuff. You can't change it, whereas you could try and hack stuff on here. So this is what we actually did. We took FFV1, and since it wasn't just a paper, it was an implementation that we could already use. And the implementation used for production, that we used for production, happened to be the reference implementation because there was no standard paper. So actually the downside turned out to be an upside, which means that there are actually no interoperability issues because everybody's using the same code. There is no need for people to write their own version of FFV1 because they can just use the one that's in existence if they want to. And, well, yeah, you don't have any black box issues. So whenever we run into an FFV1 file that for some reason happens to not make you happy and not play well, you can actually look at which version of FFmpeg was used to create this, fetch the code, and you get your replayer and schematics and building components to actually transcode or fix that file, or whatever. Oh yeah, I say FFmpeg libav libraries. This means that every program that is linking against one of these two libraries supports FFV1 out of the box. This was also a reason why we chose it, because VLC happens to be built on top of these libraries, so FFV1 just worked like this. I could even play my archiving format on my tablet or smartphone right now if I wanted to. That's not a typical use case, but it's like so much for interoperability and accessibility. Won't go into this one. We've already seen it before, an Arian slide. This is the Performa project that went through all this, which formats to choose, which ones to go for. Oh, thank you very much. Which formats to go for, and they ended up with FFV1. So we've seen this, Evan explained it, and this adds to sustainability, because now we've got the Performa project backing it up, and then there were resources to have media conch, and then you've all heard it before, I don't have to say it again, but now there's standardization in progress over the IETF. If there are any questions why the IETF and not others, I'm happily gonna answer them afterwards. So, since I also like pocket knives, they're really good. Usually when I try to explain this thing, I use a spork. That's like a spoon, a knife, and a fork versus cutlery. Why am I doing this? When the Mediatek started using FFV1, people were like, but can you do this? Can you do this? Can you do this? What about this? And we want this feature as well. And then came broadcasters with a whole list of what they wanted with it to do. I said, well, at the moment, it can't do it. And actually, we're not really interested in supporting and making everyone happy, because this is something to be avoided. I find it challenging very often as a computer guy to talk to regular human beings, as we nerds call you, or the non-programmers, how to explain people that when they go for a file format that there are differences in how it's done, what is a reference implementation, what's a feature list. They told me this format can do everything, so of course I use that format. Well, but if you would present them a physical object like this and say, this is actually what you were asking for, sir, they would go like, please, can I have this? Because, oh yeah, by the way, this really exists. I saw this image in the past, and I thought it was actually just a computer-generated graphics. No, you can buy this. It's called Wenger Giant, and I really suggest looking at the Amazon page, because the reviews in there are hilarious. They were rescuing Swiss engineers from inside slot 3235 with the built-in crane and digging equipment, and it has everything in it. But okay, I think you get my point. The all-in-one approach is something that can be good, but it can really be overdone. So we're trying not to overdo FFV1. We're trying to make it as complicated as necessary and as simple as possible. That's like a minimalistic standard. And as long as we can do this, we'll stick to this. An important factor is only lossless. If somebody asks for, can it also do lossly? No, it will always only do lossless. So this doesn't happen. So, moving on, transcoding NLE. At the time, any tool that actually builds against FFmpeg libav libraries does support FFV1. And for the time being, on the command line for transcoding, it's also there. There are other tools which usually build against these libraries. For nonlinear editing, you probably will say, yeah, but the program I use for nonlinear editing definitely will not do FFV1. It's not a technical issue. It's a chicken-egg problem. So people say, I will not use this codec because I can't edit it. And the vendors say, we will not use this codec because nobody's asking for it. Chicken-egg? That's quite, this chicken has, yeah, it's serious. So we're actually speaking about 3 applications. I probably assume correctly that you know these 3. And as I said, there is no technical restrictions from preventing them supporting another codec, for example, to have a lossless one that actually would be usable in practice. We've contacted one of them, and the answer was that they actually have legal concerns because they are afraid of getting near systems and code that is open, because it could have, from their point of view, a negative influence on the openness of their systems. From a point of an archive and end user, I don't think this is my problem. So about real-world experience. Not only at the Mediatek, but others. Oh yeah, I forgot to mention, oh my God. When we stumbled over FFV1, my colleague met a really nice guy from the other end of the world called Dave Rice. And so Dave and I, we basically got together and made sure that this FFV 1.3 is coming out. And so direct recording, there are a handful of institutions already that are just directly recording into FFV1 by using different technical means. So you don't just record into one format and have to transcode again, no, because you have to wait for real time anyway. Then there are the integrity-aware transcodings with the slice CRC. So you do transcodings and no silent errors, because if you use the version 3, the transcoder can say, it didn't work, or yes, it did work. Nonlinear editing, well, these 3 applications do not support it at the moment, but at the Mediatek we've been using open source editing programs, which I would not recommend at the moment because they're too unstable, but if you're interested, well, you can throw money at a problem to make it work. We did nonlinear editing directly in FFV1 over the network, and this as a very small institution with small budget and small infrastructure, and the editing we needed to do for clips for the web and so on worked perfectly. So we know it is possible. It's just if somebody wants to support it or not. Excerpts, something that was already mentioned before, it is possible to actually edit something and just cut at the right position and not requiring transcoding. So you just rewrite the file. Basically, it's the speed of a copy process. That's what we did a lot at the Mediatek. You know, you have the whole long material, but you want to have short clips to put online on a web page. So you just say in, out, and write the files. No need to retranscode. You just copy this from A to B. Interoperability. I must say the only interoperability issues that I've had with FFV1 so far were when I had an application that was released before version 3 was released. Since we made sure that all the changes and improvements we've done went back upstream to the FFmpeg project, and I also made sure that they went back upstream to the libav project. They're basically the same, but they forked. These interoperability problems disappeared automatically because once the developer press compile build on their machine against a recent version of FFmpeg, boom, there you go, FFV1 version 3, and it just works. We're nearing the end. Collaboration welcome. I remember on the first day, I think this was yesterday, if I remember correctly, it said that collaboration is encouraged and that this symposium is supposed to encourage and motivate collaboration. Not an open source evangelist. Actually, I'm quite pragmatic regarding this, but this is enabling and allowing collaboration by design. Apart from this, the seller list was already mentioned. So in case you're interested in FFV 1.3 and you say, if there's standardization, we want to get it right, so we better chime in, you can join the discussion on the seller lists. If you need any details, just tell me. Then there's stuff like the ecosystem around that is used when working with FFV1 at the moment. That's QC tools. It's an amazing tool. It makes analysis graphs, and you can do quality control on a basement level. It's got filters and so on, and it's basically just a graphical user interface to FFmpeg as an engine. so it can be integrated in workflows. And then there's media contra we've already heard about. And what's actually missing is an archive recording application, but there are other things like Dave, I, and others have started putting together things in this environment to make it more comfortable and more usable. And I can just invite you that if you are interested, software can be a bidirectional thing. So you don't have to just sit there and wait and say, I hope somebody does something that I might be able to use, or hope for the leftovers. No, actually, this is a proof of concept that we have common interests. Well, at least some of you and I have common interests as an archive. So we do have common challenges. And the point I'm getting at is this is a proof of concept that common solutions are actually really, really doable. I'm finished, but I just wanted to say, now imagine we did this, 2.5 guys, hardly any resources, and you've heard about this codec, not just from me. So thank you very much. Questions so far?
Yeah, so we have a few minutes for questions.
Yes.
Peter, you say that interoperability problems are not to occur because you have a stable version and v1.3 is good and out. I think that was the same, or is the same, with every new codec that is first in the market. If you now do the same and try to get others on the boat, and they should also adapt and modify the system, maybe port it to different hardware, parallel, you have open source and you have a community, and you will have interoperability issues in future. And it's absolutely clear the only reason you don't have them is because no one has any interest in that so long. And that is the reason it was stable. As you say, 3 years no one was looking. I think that's the reason, because you have no interoperability issues. You will have them and be prepared. And I think the media crunch is a very good approach to make a checker and make sure that you get not too much interoperability problems. But don't tell you don't have them. You will get them.
Oh, maybe. But the thing is that how and when, because we have regression tests in the code, and if the people are using the same implementation, it's a very good point from you. Like, I would really like to know more, because I do not see it if people use the same implementation. And if there are certain changes in the code that cause regressions, they show up in the regression tests. If there are new features added, it will not be released for use until it's marked as stable. But we can speak about this later on. It's a very good point. Thank you.
Jim.
Could you talk a little bit about audio and how you handle audio and audio synchronization?
It's a video codec.
You don't handle audio at all?
It's a video codec. The container handles the audio.
And how do you synchronize the video?
That's part of the container.
Okay.
Any more questions?
But I've made tests with synchronizing audio and video when I was testing the whole signal chain, and I'm pretty sure that it works.
Hi Peter, thanks for a great presentation.
Hey,
kept me awake despite jet lag. I just wondered, and maybe we'll take this offline, but if you could step back to the comparison diagram, because I just wanted to understand how many of the codecs were actually implemented multi-threaded. I know you said that actually the JPEG 2K...
H.264. The Rack and JPEG 2000 were not implemented multi-threading at that time.
Right. So
Right.
really the fair comparison is with H.264, which is a good comparison.
It's the link below. Oh no, it's cut off. But if you just skip the last part and go to info and video, you will get to the article. I put in all the logs of the command lines used to do this. And actually, to do this, you just have to do minus threads 1, and you get a single threading only comparison. And in that case, I can tell you that it still will be faster than the others because the algorithms used are lighter.
I think it's very interesting if you lose check, and you said you check only for single-threaded, but I think more important today, as the new generation of computers use multi-process and multi-threading, and you can use GPU implementations like we do. So you can have four streams in JPEG 2000 on a single machine. So I think the CPU count is no longer relevant to convince someone.
You mean CPU versus GPU?
No, both. You can have both. And
both what? Like CPU and GPU?
Yes.
And I'm not saying I just did single threading. I just said that they didn't. The implementations of these codecs at that time couldn't do multi-threading. This implementation, this is exactly what I'm getting at. There are different implementations which are different flavors of this. Yeah.
What I'm saying is, if you, it's not giving much value, because if you can parallelize things, for example, to 500 cores, it don't matter what a single core needs on.
Absolutely true. What's your point?
The point is that the algorithms differ in the possibility to parallelize.
Ah.
And that is.
Did you take a look at the FFV1 algorithms in comparison to wavelet transformation?
Yeah, a little bit.
Yes.
Yeah.
And they do not. They cannot be rewritten to perform on GPU.
Partly, they can partly be rewritten to work on GPU.
Yeah.
Of course. And the question is, how good is the algorithm optimized in the flow to be parallelized?
I can't really comment on this, but there's the FFmpeg development mailing list where you really get the best people to ask.
I can say that is a big benefit of JPEG 2000, that it's very easy to parallelize the process. And that is something, it's not that easy to parallelize with an FFV1's as far as I have seen.
That's very interesting. Can you point me to documentation about this or
can
your
also not
studies?
confirm this because we have also used that into very large broadcast installations, and we have multi-threads just simply going linear up to 8 cores. So I don't see the point. A CUDA machine adds another between 8,000 to 16,000 euro of a CUDA K20 to K80 card, whereas a CPU-based CPU.
Graphic cards, GPU.
Okay, but good.
No added value what you already have in your PC.
Okay.
Okay, one last comment, and then we're done.
I'm wondering whether anyone's done a patent search on the FFV1. That we've seen Samsung and Apple duke it out over whether the screen is shaped the same way. There may be no intent to infringe, but they patent everything, particularly intellectual property, whether that search has been done or whether the open source squeeze, there's a time bomb.
Yes. No. Nobody actually dug into this because if you're probably familiar with the hassle of patent research, especially patent pending, submarine patents, and so on. Why I'm presenting this is there was a question about patents of on JPEG 2000, for example, and the guy who's responsible for licensing checks of the Performer project actually went to ask around people, including Library of Congress, and they said basically they're pretty sure it's safe, but they couldn't point at explicit proof. And there
is explicit proof. The algorithms for JPEG 2000 were developed by Hewlett Packard, and they were specifically put out into public.
could I get links on this? Because it's really, this is secondhand information I'm passing on from.
It's on the internet.
No, I mean,
the seed algorithms for JPEG 2000 were developed, wavelet algorithms were developed by Hewlett-Packard. And they decided they weren't going to do anything with it. It was then picked up by Kakadu, and then they went further. And then they then license it. There's a small licensing fee, not to end users, but to manufacturers. But the seed algorithms for JPEG 2000 were developed by Hewlett-Packard.
Oh,
And
that's
they
fine with me.
were put out in the public domain. So that's your answer.
Because when, as I said, for me it's secondhand information that the guys from Performa who did this told me that they didn't get any concrete proof. But if it is, I just...
Just take a look.
Oh, great. The other thing, if there are patents on it, basically, as an archiving institution, I do not have to care because they don't apply to the source code.
But Christophe does.
Well, but that's his problem, not mine. So as long as I have... As long as I can compile the source, and it's actually pretty simple in this case, I can gain access to this format. And then if this should ever happen, that there's a problem with patenting, then first of all, we're in Europe. So then the question is, where does the patent apply? It does not apply to the source code. So what I do is I can compile the source code, get out of the format, and do whatever then. So I think we'll think about crossing the bridge when we get there.
I would like also to say here that the adoption level of FFV1 came to a certain point where we do not discuss an immature birdie hipness idea, because as you are quite aware, the Indiana University, one of your clients, has committed to FFV1 and MKV container as well. And it's just one of, I think, 10 institutions in the US who has done this, as far as I know, from maybe pre-serve, maybe it's 5, I don't know, I don't have the exact list. Adding those whom we did, it's getting a substantial weight. And I'm sure that if, in this case, there is an infringement issue, we looked into it, and actually, technology-wise, well, you never know. If there is a substantial threat to industry, there is always an infringement, and you can just also face that. But at the moment, technically speaking, and from all the implementations, what we've done, it's really a very nice tool to do.
Right, well, thank you, everybody. You've managed to get to the end of the second day. Well done, and thank you very much to our panel.